Good afternoon, Nana, everyone. Yeah, yesterday I think I explained about the conservative and non-conservative forces, how you distinguish with respect to the work done. Okay, I thought that all of you understood that concept and no doubts they're related to the conservative and non-conservative forces. Shall I move to another concept here, Nana? Yeah, thank you. Good. Moving to another concept here. Thank you, thank you. Thanks, girl. Thanks for giving the permission, Milord. Uh, yeah, thank you. Then here coming to the concept, of course, you know it, nothing to explain there about it. That is the other type of mechanical energy. It is the kinetic energy. Okay. So by virtue of change of position, you will get one kind of mechanical energy, that is potential energy. Related to that, we did many problems and we discussed the total concept related to it. Okay. And the kinetic energy concept here. Kinetic energy, the body gets this kind of energy by virtue of its motion. So directly I write that point here, by virtue of its motion. Oh, sorry, it means who is this? By virtue of motion of a body. Motion of a body. Okay, is the energy possessed. Okay, mechanical energy. Mechanical energy possessed is called kinetic energy. Okay, I think nothing there to derive the formula for it. All of you know it. Kinetic energy, of course, if you represent with the letter K, then I write that kinetic energy is equals to half mv square by virtue of its velocity. Okay. Yes, this is the kinetic energy here. Okay, nothing new. All of you know this formula. And related to it, sir, if I move one body from a height h1 to a height h2, then the amount of work done you related with the potential energy now. That potential energy is final potential energy minus initial potential energy. That is here mgh2 minus mgh1. That day we concluded one statement also. Okay, the work done may be equal to the change in potential energy. I think all of you remembered all these points. Am I correct, Nana? Yes, yes, I think all of you remembered that work done is equal to change in potential energy. Yes, yes. In the same way, if the velocity is changed, then will you prove that the work done is not change in potential energy, that is change in kinetic energy, sir? Sure, that is a simple question. Okay, not silly question, it is a simple question. Okay, very simple. Even you also can derive if I won't explain. Okay, so here, suppose if he says, by applying a force of F, whether it is variable or constant, whatever, the body gets a displacement Suppose in the same direction. Excuse me. Displacement in the same direction. Oh, same direction, sir. Means you are saying that angle between force and displacement is 0. Theta equals to 0 between them. Yes, in the same direction. Okay. Since force is in the direction of displacement, anybody can understand that its velocity increases. So the body gets a displacement in the same direction. Better we put the full stop there. And then I write here its velocity increases from some value to some other value, right? I write here its velocity. Why? Because displacement and force are in the same direction, Anna. That's why velocity increases. If force is applied in opposite direction, then velocity will be decreased or increased, Nana. If force is applied in opposite direction, whether the velocity increases or decreases. Decreases. Very good, very good. Since I applied here, yes, correct. The force, there is, it slows down. Very good, correct, Shrestha. Okay, in this case, velocity increases. Why? Because force tries to increase the velocity. So its velocity increases from certain value, say some u initial velocity, to final velocity v. Suppose given like this. Okay, Nan? Then here you can easily prove that the work done is change in kinetic energy. Very, 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 very easy. How, sir? Simple. W is equals to what you say. Since they are in the same direction, I can write integral either f dot ds or simply f into s. Sir, which one we prefer, sir? That is your wish. Anyone you can take. Better you explain both, sir. Very smart boy. Okay, I will explain both. No problem. That is equals to integral. F, I write it as M. Oh, sorry. I write it as M into A dot ds, or good, sir. You explain the other one also, sir. Yes, M A into S. I think no need to put the dot product. Why? Because both are in the same direction. In the dot product, cos 0 becomes 1. So in the next step, without dot, straight away I write it equals to, okay, this is equals to, I write, right. This is equals to m constant taken out integral a into ds without dot, or other one is MAS. Okay, sir. Then what you do, sir? Simple. A, I can write in differential form either dV by dt or V dV by dx. Any one I can write. Sir, better you prefer the second one, sir. Why, Ranana? Sir, here ds is there now. So in place of dx, if you write here V dV by ds, then ds get cancelled now. Wow, good idea. Right. I prefer that one also. That one only here. Good boy. So I wrote instead of a V dV by ds, Nana, into ds. Good, sir. Next, or this is equals to m into, better you do one thing, sir. What, Ranana? This AS you multiply with 2, divide with 2, sir. Why, sir, you can understand, sir. Just look at this one. Are you not getting any idea with 2AS? Any equation? Yes, Nana, I am getting some idea there. After cancelling ds here, you are saying that, good, Lakshmi Gayatri. M by 2 into 2AS, yes, V square minus U square. Correct, Shrestha. Okay. Good, sir. Now here, even this integration also, you will get integral v square by 2. Very good. Or without integration, already you got the answer. If you multiply half mv square, first term, minus half mu square, the second term. Even here also you get the same, Nana. How, sir? Simple. You did not substitute the limits. Substitute the limits, you will get the answer. Correct, sir. Limits from u to v. That's what I told. Changes from u to v. Therefore, here also you are getting the same answer. First upper limit half m v square. Next lower limit half m into u square. There or here you are getting the same formula, which is nothing but change in kinetic energy, K2 minus K1. Oh, I understood logically one point, sir. Yeah, good boy. What you understood, Nana? If only the potential energy changes, work done is equal to change in potential energy. Yeah, good answer. If only kinetic energy changes, work done is equals to change in kinetic energy. Very good. That's why even here also you can write one extra point, sir. The work done may be equal to change in kinetic energy. Oh, this statement is also correct. Yes, sir. Okay. And one more you can say. The work done is equal to change in kinetic energy. You observe whether you go with integration or without integration. Observe here, you got the same answer. That's why here directly you can conclude one more point. The work done, okay, is equal to the force which is doing the work. Is uniform or non-uniform. Is this statement correct, Nana? The work done is equal to change in kinetic energy, whether the force is uniform or non-uniform. Yes, correct. Yes, good. Okay. Who is this? First time I'm seeing. Realme C15. Wow. Who is this Realme? Oh, Ishan boy. Array, what is this Ishan boy? Okay. I thought that that fellow is this Realme. That is you. Okay. Right. Good. Right. Then here, this is the statement about the kinetic energy. Okay. And that kinetic energy you can apply anywhere, whether the force is uniform or non-uniform. Okay. And here, suppose not only the potential energy, but also the kinetic energy simultaneously changing. Okay, Nana. Indrakanti Anvita, sorry. Who is this? First time I'm seeing here in chat. Indrakanti Anvita. Okay, Nana, no problem. Oh, Anushka. Okay, right. Okay, Nana, no problem. Right here, what I said, if not only the potential energy, If only potential energy changes, already you proved that W is equals to U2 minus U1. And only kinetic energy is changed. You already proved again today only K2 minus K1. Okay, here only kinetic energy is changing. There only potential energy is changing. Okay, sir, how, sir? Array, what is this question? Suppose here, instead of throwing a stone upwards, I hold the bag and lifted that bag to place here at the top. Okay, means in the rack or somewhere. Okay, just I'm not throwing that into the rack now. I'm holding and placing in the rack. Why? Because it is my favorite physics book. Okay, so I am here placing. There I'm changing only potential energy without giving kinetic energy. Keep in mind. Okay, and number two, suppose if I find in my house, okay, some here like, of course, chemistry book, then immediately I throw that to a corner. Okay, I won't place it in the rack here. That time I'm giving only the kinetic energy without giving any potential energy. So here in case of chemistry book, I'm giving kinetic energy. In case of physics book, I'm giving the potential energy. Then what you do with mathematics, sir? Mathematics, I play with maths. Why? Because I'm a physics lecturer. Na? Physics lecturers play with maths in their physics. What you play, sir? Simply, I won't throw that to the corner. Why? Because I require mathematics. Okay, that's why simply I throw that just to fall in the rack. Exactly. Okay, that time you observe, I am giving the potential energy and throwing, giving the kinetic energy. Means simultaneously I am changing both potential and kinetic. At that time, what happens? This one we are checking here. Okay, right. Come to your cross checking. What you did? First hold the math book, sir. Okay. Then throw it, sir. Where? Not on our face. Throw upwards. Where to fall, sir? In the rack. Okay. First throw it upwards. Okay. Thrown, sir. Here. Like this. With a velocity u. Okay. Then what happens? What happens, Intra? Silly question. It goes up. Okay, sir. Sorry. It goes up. Then what happens, sir? Okay, suppose not thrown properly, it goes to a maximum height and again falls down. Oh, acha. It goes to the maximum height and falls down, sir. Yes. At maximum height, observe the velocity is equals to 0. Yeah, that we know, sir, in motion in a straight line chapter. Okay, good boy. V equals to 0 at maximum height. Oh, you are saying that it is the maximum height, sir? Yes, exactly. This is the maximum height. Wait, sir, we try to recollect the formula for maximum height, sir. Oh, long back you said, sir. We are trying to recollect. Anyone please help? What is the maximum height formula? Would you please help me? Thank you, Shrestha. Yes. Oh, many knows this formula. Yeah, u square by 2g. Very good. This is the maximum height. Very good. And here it is thrown from this ground level. From that ground level means it is my reference level. At the reference level, would you please help me again? What will be the height of the body at the reference level? Wow, thank you, Amok. Thank you. It is 0. Very good. Will you please tell what is the height here at the maximum height? At that height. Shall I write it as capital H? Right. Good. H. Right. That H, shall I substitute if required u square by 2g? Very good. Right. So I'm going to check here. Look at While going up, the height changes from 0 to some maximum value, h. Means height is increased. Keep in mind, height is increased means potential energy increases. Okay, that point only I am going to write here. When a body is thrown vertically upwards, okay, then yes, that only I am going to say, Lakshmi Gayatri. Yes, that only I am going to say. That is my intention. Okay, you read my heart. Exactly, that only I am going to write here. When a body is thrown vertically upwards, then it's what exactly you wrote. Height increases, thus its potential energy increases, and yeah, potential, yeah, that only Amok. Yeah, exactly. And on the other hand, look at the velocity decreases. Yeah, yes, from u to 0. Thus, kinetic energy decreases. Okay. So potential energy is increased, simultaneously kinetic energy is decreased. This one what you learnt in your lower standards. Kinetic energy decrease means loss in kinetic energy. That already you know is always equal to gain in potential energy. Okay, that I am going to prove here. Okay, so suppose this is the point A and that is the point B. Look at the 2 points and I am going to write the next one. At A, potential energy is equals to 0 and kinetic energy is equals to half mu square. Okay, any mistake here, Nana? At the point A, is it correct? Yes, no mistake. Very good. Potential energy is 0 and kinetic energy is half mu square. Okay, and at B, next one. At B, observe here, potential energy is equals to mgh, capital H, and kinetic energy equals to 0. Okay, so if you observe, that implies gain in potential energy is equals to 0 to mgh increased. So this is mgh, and loss of kinetic energy, loss in kinetic energy, Ke is equals to, I write here, that is loss, half mu square to 0, decrease. That's why loss is half mu square. Don't write minus, Nana. Already I wrote, instead of minus, it is loss. Okay. And here, formula wise, if you see, these two are not appear to be equal. Okay. But once you check, they are equal. How, sir? Mgh is equals to half mu square. Array, simple, Nana. Just expand this step. How to expand, sir? Yeah, same only, exactly. Mg in place of h substitute u square by 2g. Okay, then g cancel. If you cancel the two terms here, you will get there exactly equals to half mu square. Okay, both are equal or not? That implies I can conclude loss in Ke is equals to gain in Pe. Yesterday we used this concept in problems also. Loss of kinetic energy or loss of potential energy is equals to gain of in another energy. gain of any other. Okay, good. And here, this one, you know, in your lowest standards as law of conservation of energy. If that loss is equals to gain, then we say it comes under law of conservation of energy. Yes, law of conservation of energy. That one I am saying like instead of loss or gain in 10th class. Yes, yes, yes. That's what I'm saying, Deepali. Okay. Oh, it is in 9th also now. Okay, okay, right. No problem. Then I'm saying here in terms of total energy, Nana. Very good, very good. Total energy. Yes, yes, yes. Okay, good. Total energy means potential plus kinetic. That is 0 plus half mu square. That is equals to half mu square. Okay. Even at B also you will get same mgh plus 0 at B, that is also equals to mgh. No need to explain again the same steps, copy and paste here. mg into h is u square by 2g. Again g cancel. This one also you are getting half mu square. This is at A and this is at B. Yes. Therefore, total energy is constant or variable? Is it constant or variable, Nana? Total energy, total. Yes, yes, yes. That implies we are going to conclude here. Total energy is here constant. This is called as, that implies total energy is conserved. Okay, it comes under law of conservation of energy. Okay, this is the brief explanation for law of conservation of energy. Sir, this is known thing only now. Why you explain, sir? Why merely wasted our precious and most valuable time, sir? No, Nana, I did not waste. This is mere waste only, sir. We know it. All those things we know in lower standards. Wait, Nana, simple. You can understand one point here. What is that point, sir? Here, if I say the statement, the work done, okay, by all conservative forces is equal to, or like in the previous statements, may be equal to, any word you can use there, may be equal to change in total energy. If I write this statement, is this statement correct or wrong? Lakshmi Gayatri is saying that it is correct. Okay. Others? Deepali is also saying correct. Okay. Tanisha is Tanisha, what is this ray? Once think. Lakshmi is Satvika also saying correct. Ishan saying correct. Varun saying correct. Anushka also saying correct. Okay. Yashashwini is saying correct. But Amog did not respond. Srivalli, okay. Srivalli, okay, after long time. Oi, maybe or may not be, don't say like that. Sure shot, okay. Like Raviteja crack, sure shot, pucha pelipotundi. Like that you have to say. Correct or wrong, that's it. Don't say maybe correct, maybe wrong. Why? Because today maybe Manibabu is not there. Yeah. What is your sure short answer? Amok. Wake, correct. Oh, this time sure shot, correct. Okay. But keep in mind, this is Deepali, why you changed your mindset? Nah, total energy is constant, ra. Constant means change in total energy is equals to zero, Ranana. Then where is the work done? There is no work, na. Work is done to change the potential energy, to change the kinetic energy, not to change the total energy. Keep in mind. Okay, you only see here, you found some change in potential energy, you found some change in kinetic energy. You observe here, total energy is changed. Half mu square at A, half mu square at B, total energy. It is not changed. It is not changed means work is not done to change the total energy. If you followed my explanation, now you say the answer. Now that statement is correct or wrong? Now Lakshmi Gayatri changed. Yeah, point of view. Yeah, Deepali, yes, correct. So it is wrong statement, not the correct one. That's why I explained this part, Nana. Even though you know it, just to show that total energy is constant by the total is constant in case of conservative forces, gravity type of forces, Nana. That's why I explained with a body thrown vertically upwards. Means here potential energy is changed by gravity, kinetic energy is also changed by gravity. So gravity is a conservative force. Yesterday I explained. I think all of you remember. So work done by conservative forces, okay, may be equal to change in potential energy, change in kinetic energy, but not equal to change in total energy. Yes. That's what I'm saying, Lakshmi Gayatri. Yeah, that's why statement is false. But you told initially it is correct na. First you only responded. Okay. All they followed your steps only. Okay. You are Mahatma Gandhi to them. They followed your steps. Okay. Right. You are correct. Now you are correct. Okay na? Gandhi madam. Yes. So Subhash Chandra Bose. Okay, right. Right. So this statement is wrong. That's why I'm writing in red color. Yeah, this statement is wrong. Yeah. Change. That's why I told previously the two statements here. The work done is equal to change in kinetic energy. Yesterday I told the work done may be equal to change in potential energy, but not equal to change in total energy. This was one advanced question and multi-answer type questions you can find in advanced exam. One time he gave first statement what I said, work done may be equal to change in potential energy, first option. Second option, work done may be equal to change in kinetic energy. Third option, work done by conservative forces is equal to change in total energy. But fourth statement also you have to come to know that I'm going to write here. The work done by non-conservative forces may be equal to the total change in total energy. What do you say about the fourth statement he gave in advanced exam? I think about 1, 2, 3 you can say. First statement is correct, second statement is correct, third statement is wrong. What about the fourth statement? non-conservative force. Okay, correct, but with many question marks. Okay, then look at my example here to understand first. Here he said one thing, Nana. What? Sir, a body is thrown. Better I write the mass here. Why? Because we require it. A body of mass 1 kg is thrown vertically upwards with a velocity 10 meters per second. Okay, Nana? Take g is equals to 10 meter per second square as usual. 10 meters per second. Okay. Throw. Oh, spelling wrong, Nana. Oh, sorry, sorry. Right. Okay. Don't hesitate there, Nana, here to say like, no problem. I will correct it. This is the crack effect. Okay. Thrown vertical upwards with a velocity of 10 meters per second, g 10 meter per second square, take it. And he is saying that, okay, the gain in potential energy by this velocity is 80 joules. Okay. Find the work done by the air resistance. Okay. This is the question, Nana. Try to understand the question. Here, when it is thrown vertically upwards from the ground level like this, from the ground level here, with a velocity of 10 meters per second square, observe what is the total energy at the initial point, Nana? At A, total energy is with the previous explanation 30, Nana. Lakshmi Gayatri, check it, Nana. Without checking, don't say. Okay, total energy is half mu square. No. This yeah. Total energy is 50. Correct, Srestha. That is half. Sorry. This is not 80, Nana. It's my mistake. Again, crack problem. This is 30 joules. You take it. Okay. Half keyboard error. Okay, right. Half m right 1 into u square, that is a 10 square. Okay, you are getting total energy at A. I got even you also will get, that is 50 joules now. 1500. Golapudi, what is this? 50 kada? Right. Total energy at A is equal to 50 joules. That's why, according to law of conservation of energy, total energy at B should be 50. But look at that, he gave the gain in potential energy. Gain in potential energy is nothing but the total energy at B. I think all of you know it. But given that total energy at B, which is equal to the gain in potential energy, that is total energy is equals to at B is 30 joules. Means, does it violate the law of conservation of energy? Total energy at A is 50. Instead of getting 50, I got 30 at 20. Means what you are saying, sir? Total energy at A is not equal to total energy at B? No, no, no. This is not my intention. There, observe the air resistance he considered. Air resistance is not a conservative force. It is non-conservative force. Okay. So in case of non-conservative force, total energy at A always not equal to total energy at B. There will be some work done by non-conservative force. That's why here that implies air resistance. Now I can erase the statements here. Air resistance, which is non-conservative force, okay, did some work. Okay, that implies in case of non-conservative forces, work done may be equal to change in total energy. Now you understood, Nana, what I'm going to say here? All of you. Yes, that's why here air resistance is non-conservative. That's why total energy is surely not equal to total energy. We have to add extra the work done. That implies total energy at A is equals to total energy at B. Sorry, you wrote wrong, sir. Hey, don't shout. Wait, I complete the first the line here. Plus work done. Yeah, thank God. Now you are right, sir. Is it correct, Nana? Good. That implies work done is equals to total energy at A minus total energy at B. That implies total energy at is 50, total energy is with 30. So W is equals to 20 joules. Yes, by air resistance. Exactly, Tanisha, by air resistance. That's why, is this statement correct or wrong? Fourth option here given in advanced exam. Correct. Yes, you can conclude that. Okay. So here, last but not least, I'm going to write this statement. Oh my goodness. For just one line, I have to turn one more page here. Okay, no problem. Here I write what? If the force is non-conservative, then the work done may be equal to change in total energy. Okay, right. Any doubt here, Nana? What I explained today, the concepts about the law of conservation of energy and kinetic energy? Yeah. Okay, no problem. Right, no doubt, no doubt. Then happily, if you want, you can take the pages. Otherwise, Jai Hind. Okay, Nana. First page. Okay. Second page. Thank you, thank you. Third page. Okay, Nana. And last page. Jai Hindra. Okay. First page, Nana. Sure. Anushka, take it. Okay. Bye, Nana. Bye, everyone. See ya.